Hi everyone, my name is Carson and I'm a senior mechanical engineering student at CSU Chico. I've been a part of our Baja SAE team for about 3 years now, and as a design lead, one of the questions I get asked a lot is what is FEA and how do I use it to help me in the design process? I figured it would be worthwhile to make a short video series to answer those questions and help young engineers get a basic understanding of the tool. The demos I'm going to be doing are using SAE Baja parts, but the principles are going to be the same no matter what you're working on. So let's get into it. FEA stands for Finite Element Analysis, which is just a fancy name for solving a huge system of equations. In its simplest form, FEA is basically taking your model and turning it into a giant mesh of springs. If you've taken material science, you know that there's a linear elastic region of the stress-strain curve for any given material, and in that region, the material acts as a linear spring. So what that means is that if you stretch it and release it, it'll go back to how it started. Now the method gets more complicated than that, but this is a good starting point for understanding what the computer's doing. So here we are in Solidworks with our model opened up. This is a hub for our 2017 car. If you come up here, you may or may not have this Solidworks add-in bar. If you do, you can go ahead and click on that and add in simulation. Usually when you open Solidworks, it won't have the simulation package added in. It may have Simulation Express, but we're not going to be using that because it's kind of a lesser tool. So if you have the full simulation package, always use that. If you don't have this bar right here visible, you can go up to the little options gear, hit the drop down, go to add-ins, and then here, this shows all of your add-ins. So that's kind of a quick way to get to your add-ins there. And so you can just click SolidWorks Simulation, hit OK, and then it'll load in just a minute. And there you go, you have your simulation tab. It's all going to be grayed out because you don't have a study started just yet. So to get a study started, go over to here. Don't use the advisor. The advisor sucks. And it's just not a good way to go about doing your FEA. It's just not good engineering. So go to New Study, and this will give you all the options. So SolidWorks can do all sorts of fun stuff here. Today we're going to be doing static, because that's kind of the most basic one, and it's a really good starting point. So static, it's selected, hit OK, and there you go. Now you are in a study. So if you go down here, you can see the tab is no longer in the model view. It's in the static 3. I have these other two just from earlier messing with it. And over here you can see the tree changed. So you still have your standard model tree there, but it's not that important in the simulation here. So now it shows you all of this stuff. The first step that you want to do is come up here and apply your material. So your model will not run if you don't have a material applied. If you have it applied in the main SolidWorks model area, it sometimes will cross over and already have it populated. Sometimes it won't, or you may not notice. It could just be an undefined material. So here I'm using 75 T6, hit apply, and close it. So what that does is it basically gives the algorithm the properties for this material in order to let it run the simulation properly. Okay, and so SolidWorks kind of lays this out nicely where you go from left to right basically in your whole simulation workflow. So the next thing that you're going to do is come over to the fixtures. Again, don't hit the advisor. The advisor is default on all of these here, which is kind of annoying. So I always go to the drop down, and you have a couple different options for fixtures here. Fixed geometry is the most simple. So basically, if you define something as fixed geometry, it's going to be stuck, so it cannot move at all. Roller slider, it's a little different. It's fixed in a direction but can move in the other, so that's useful in some situations. Fixed hinge is basically what it sounds like. It can hinge. And elastic support, I've never actually messed with that. So fixed geometry is one of the easiest to use, and it's kind of one of the most easy to think about. So this is by far the most important part of your simulation and getting accurate results, is this whole setup process here. So when you come over here to fixed geometry, you can kind of see a little animation of what it's doing. If you don't have your fixtures correct, your simulation is basically going to mean nothing. You really have to think about how the part is going to be loaded in order to define this properly. So for example, if you just fix the front face here and, I don't know, applied a load down here on this surface, what is that really telling you? Is that how the part's going to be used in competition? Maybe not. So what I'm going to do is I'm going to come around to the back here, Basically, what I'm going to be doing right now is I'm going to try to simulate an impact on one of these tongues. So basically, you have the rim bolted on here, and let's say the Baja car starts sliding sideways, and we hit a rock, and it slams in. Basically, worst case scenario, and all the force is directed onto this one tab. Now, that's not a super accurate simulation, I guess you could say, but it's a really good starting point to give you kind of a ballpark estimate of if this part's even going to be close to working. So what I want to do is I want to fix these inner surfaces, because I know on the car they are actually going to be basically stationary if we think about it. Okay, so this, I'll just do a couple of these in here. This one, this one, this one, this one, and I'll do this back face because I know that's not moving anywhere. Okay, so fixed. So those things cannot move. Now, if you were to grab onto this part basically and try and yank it around, it's going to be stuck at those points. So think of it as a really strong super glue. Now, I added a split line here in the model. If you don't know how to do that, I recommend you look that up somewhere else. It's a really useful tool in general modeling practices. But what that's going to allow me to do is to put a force only on this little region. It's not going to populate into here at all. So that's the next step. Go to your external loads. Again, not the advisor. Hit the drop down, and you have all these different kinds of loads that you can put. So Solidworks is really fancy. You can do temperature, distributed mass bearing, centrifugal, all that fun stuff. Just a basic force is the easiest to use. I use torque quite a bit too. Let's go to force. Okay, so it's as it sounds like. You see little arrows jumping around. You basically click on a face, and it's going to put a force in it. So you can direct which direction the force goes to. So I'm going to click on this one here, and for example, say you wanted that to actually be pulling, you can come over here and do selected direction and change it, or reverse direction. Okay, now the force is something that you have to define pretty well. This is probably the biggest point where you can mess up your simulation. Loading conditions are tricky to kind of figure out what they should be. If you come to design judging and you say you chose a loading condition, I can almost guarantee you the judges are going to ask you how you came up with that number. So in this case, I don't know how we came up with the number. I'm not the engineer that came up with this. I'm going to go to English units here, so that changes it to pounds. We like to use freedom units at our school. And I'm going to select 2,200 pounds. There we go. Okay, so you can see down here, force value 2,200 pounds, and that is per item. So if I had multiple faces selected, you can make that per item, so each selection, or total. So if I selected, all 4 of these faces, I can make it a total force, or, on each tab, which is kind of ridiculous. I'm not doing that in this case. All right, so you have that defined. Go ahead and hit the check mark, and there you go. You have a force and a fixture. So what's next? Basically, that's it. These arrows can get kind of unwieldy, so what I like to do is if you right click on here, you can hit hide. Same deal with this, hide. They're still there, it just doesn't gum up your screen, and it kind of makes things look a little cleaner. Now the next most important step is the mesh, so I'm going to talk about that right here. You got the mesh. Okay, if you were just to hit run the study right now, it's going to create a mesh for you and run the study. So in some cases that works. It might be worth it just to get a trial run in, but what I like to do is to come over here, right click, and say create mesh, and this gives you all the options for creating your mesh. So I haven't really explained what the mesh is. Basically, it's that mesh of springs that I talked about earlier, and it's defining how the algorithm is processing your model. So you can see you can select coarse or fine. Down here it gives you all sorts of fancier options. I don't know if I'll talk about those yet. It's safe to just stay with this normal mesh slider. It does a pretty good job. So I'll create the mesh, hit OK. Let it do its thing, and there you go. So all of these little sections are called an element. So these are triangular elements here. And at each of these points is a node that has, oh, I forget, like 9 equations or so defining how it can move. So that's what that system of equation solver that I mentioned earlier is. All right. And in the next video, when I talk about running the simulation and getting the results, this mesh is going to come into play quite a bit more, because this is actually really important in deciding if your results actually mean anything. Excuse the semi-truck driving by. Alright, so that's basically it for the setup. So don't take this lightly, because the setup is probably the most important thing that you can do in your simulation. You can run all the simulations you want, you can have a really fast computer, and it's going to mean absolutely nothing if you don't know how to set it up properly. So just as a recap, you need to define your material, select good fixtures, and define your loads. And the fixtures and loads are going to make or break your simulation. I can't stress that enough. If you load it in a way that's not actually going to be used, it's not going to tell you the results that you're looking for. And if your fixtures are unrealistic, then again, it's not going to tell you what you're looking for. So I'll see you in the next video when we run the simulation and see what happens.